These are the solutions to the Module 7 practice problems. I've highlighted the important information and I will use red ink as I go along and mention each part. For 1A, if we're looking for whether those two rectangles are similar, we want to check that their corresponding angles are congruent, and since they're all 90 degrees in every rectangle, that would be good. It passes that test. However, if we check if the sides are proportional, they are not. I can tell by comparing each pair of sides, the 8 centimeter to the 16 centimeter side, that gives me a scale factor of 1/2. And if I compare the other pair of sides, if they're similar, I should get the same number, but I don't. 10 centimeters divided by 18 centimeters is 5/9. So those are not similar. For part B, I can tell they're not similar because the corresponding angles are not the same. This one's 90 degrees, this one's not. For number 2, the angles you can start with for either A or B. We're given this 52 degrees and opposite angles are congruent, which makes this 52 degrees. And then the sum of the angles in any four-sided figure is 360 degrees. So I can subtract those two 52 degree angles and I'm left with 256 degrees to split between the remaining two, which makes them each 128 degrees. To get the side lengths, I can multiply the sides I have by the scale factor. So for part A, I'd multiply each of those by 4 3/10. And here is what I get. And for part B, I would multiply the 15 meters by 3/5 and the 5 meters by 3/5. And those would be the new side lengths. And part C, those are parallelograms as well. For number 3, I like to start with the angles first and label all the pairs of corresponding angles. So we've got 36 degrees here, 36 degrees here, 102 degrees here, which means 102 degrees here. And then I don't know X or Z, but I do know the sum of angles in every triangle is 180 degrees. So if I do 180 degrees and take away the 102 degrees and 36 degrees, I'm left with 42 degrees, which means Z and X are each 42 degrees. To find the scale factor, I've got that down here. Use one pair of corresponding sides. Remember, the new side divided by the old side gives you the scale factor. The only pair of sides where I have both values is the green highlighted sides here, the 15 3/10 and 7 3/10. If I divide those, I get about 2 1/10, which means that's the scale factor. So I can find the side lengths by either multiplying or dividing by the scale factor, depending on if I want a bigger number or smaller number. To find T, I can do 10.2 meters times 2.1, and I get about 21.4 meters for this side. And for S, I want a smaller value, so I can do 25.5 meters, divide by that 2.1, or 2 1/10. And for S, I get about 12.1 meters. Okay. Number 4, I'm going to post later because it's going to require me to print out and use a ruler for that one. But your answer should be about 119 kilometers. If you want a hint just to see if you're on the right track, you can measure these lengths with a ruler. And we have a scale factor for this first map. We know that this length is 25 kilometers. We can use that in a proportion to find a scale for the second map. And then that can help us find the distance from Mayberry to Greendale. For number 5, I started by drawing the two triangles separately so they weren't overlapping up here. Here's the smaller triangle, and here's the bigger triangle. Then I can set up a proportion with corresponding side lengths. So I can compare 6 feet to 10 feet and X to 1,050 feet. There's several ways to solve proportions. One of the ways you might be most accustomed to is to cross multiply and divide. That's fine. What that's basically doing is just solving the equation algebraically. And so if you want to solve the equation algebraically, those steps are here. Either way, we get 630 feet for x. For number 6. Again, I started with the angles. So we've got 112, 112, 73, 73, 64, 64, and we don't know G or J, but I know the total of 4 angles in any quadrilateral, the sum of those measures has to be 360 degrees. So if I subtract the ones I know, I'm left with 111 degrees for each of those. Okay. For the side lengths, I want to find the scale factor using a pair of sides that correspond, that match up, okay, where I know both values. That would be the 15 inches and the 12 inches. Okay. 15 inches divided by 12 inches is 1 25/100, okay, or 1 1/4. So again, depending on whether you're looking for a bigger value or smaller value, you can multiply or divide by that. If we start with finding x, I want a smaller value than 10. So I'm going to take 10 divided by 1.25, and I get 8 inches for x. For y, I want a larger value, so I can do 10 times 1 25/100 or 1 1/4 to get 12.5 inches. And for z, I'm going to use this 3 inches and multiply it by 1.25 to get 3 75/100 inches. For number 7, we're looking at if Jamesia did the correct model for her chest of drawers, her dresser. Okay. It tells us here what the scale is. It says 1 inch represents 12 inches. That means 12 inches divided by 1 inches. The scale factor is 12. So if I take her model measurements and multiply each of those numbers by 12, I get 30 inches by 24 inches by 24 inches. And that's not what her actual dresser is. Okay, that's not the measurements listed here. So that means that the model is not correct. For number 8, the part that finds the surface area and the volume, those should be reviewed from modules 5 and 6. But as far as drawing the drawing, here is what the smaller rectangular prism might look like. Okay. And to get the bigger one, we can multiply each side length, each dimension, by the scale factor. It might be easier to think of this 250% as 2 5/10 or 2.5. Remember, percent means per 100. So I can divide 250 by 100 to get the numerical scale factor there. Once you have the new dimensions, okay, you can find the surface area by finding the area of all 6 faces. The top, bottom, left, right, front, and back. They're all rectangles, so they can all be calculated doing base times height of that face, or length times width. Okay. And I've got those 6 calculations here. And if you add them all up, your total surface area is 2,237 5/10 square centimeters. For volume, since it's a rectangular prism, you could do length times width times height, or the volume equals the area of the base times height. I chose to work it out this way. Okay. And you see we get 6,562 5/10 cubic centimeters. For number 9 and 10, key information is at the top here. Perimeters are related by the scale factor. Areas and surface areas are related by the scale factor squared, and volumes are related by the scale factor cubed. In class, remember we talked about if you know what kind of units you're working with, okay, units or units squared or units cubed, that tells you which part of the scale factor to use or what to do with it. Number 9, we've got 2 polyhedra that are similar. The scale factor is 4. Okay. Says if the surface area of the smaller one is 250 square centimeters, what is the surface area of the larger shape? I know that similar figures are related. Their areas and surface areas are related by the scale factor squared. The scale factor was 4, so the scale factor squared is 16. So I've got 250 square centimeters, that was the smaller measurement, times 16, that should give me the new surface area, or the bigger one, 4,000 square centimeters. For B, same thing, but we're talking about volume and cubic units, which means I need the scale factor cubed. 4 cubed is 64. So I can take the smaller volume times the scale factor cubed, which is 64. That gives me my new volume of 16,000 cubic centimeters. For number 10, we've got new figures. We're talking about triangles now. Our scale factor is 1/3. The perimeter of the larger triangle is 90 centimeters. What is the perimeter of the smaller triangle? So we want a smaller amount. Perimeters are related by the scale factor. So I can do 90 centimeters times the scale factor, 1/3. That gives me 30 centimeters for the smaller one. For B, same thing, except we're dealing with area, so we want the scale factor squared. 1/3 squared means 1/3 times 1/3, which is 1/9. You might be tempted to do 20 square centimeters times 1/9, but that's going to get you a smaller amount, and we're looking for the area of the larger triangle. So we need to either divide by 1/9 or multiply by 9. So we get 20 square centimeters divided by 1/9 equals 180 square centimeters. I hope these explanations were helpful for you. I'm more than happy to one-on-one Zoom with anybody that would like to. Just let me know. I will see you next week.